Yeah, let's get started. All right, so here we're going to do combining of functions. And so the first one is algebra functions. Here we can just add functions. We can add two functions, or you can minus two functions, we can multiply two functions, or you can divide two functions. It's really kind of straightforward. We'll go through it real quick. The domain is the intersection between the two functions. So if the domain of f is a and the domain of g is b, it's the intersection between those two. The only thing is that when you divide out g, you have to throw everything, which is 0 away as well. Okay. So let me just crunch through this real fast. I don't know how deep I'll go into some of this. This is really kind of basic, but we'll do it. All right, hold on. I lost one of my little things. There we go. All right. So let's do this one. So here, if I have f of x is the square root of x plus 1, and g of x is 3 of x plus 4. So find these and the domains. So let's do this real quick. So let's just say, so if I add two functions, it literally means, so this is equal to the square root of x plus 1 plus 1 over x minus 4. So literally what you do there. So that's how you add the functions. This one be square root of x plus 1 minus 1 over x minus 4. This will be square root of x plus 1 over x minus 4. And so here, when I rewrite each one of these, you just literally do the operation. The only one that's slightly interesting is this one, which we'll dive into a little bit. Here I want to find f of g plus 3, but there's an easier way of doing this. What's f of 3? F of 3 is 2, right? The x squared, or 3 plus 1 is 4, square root is 2. G of 3 is equal to 1. Hold on, G of 3 is equal to negative 1, because I'll have 3 minus 4, which is 1 over negative 1, which is just negative 1. So if I have f of g of 3, this is literally the same of doing f of 3 plus g of 3, which is 2 plus a negative 1, which equals 2 minus, or which equals 2 positive 1. If I minus the 2, the f of 3, can I plug it into here? Yeah, I'll give me the exact same answers. But here, if I just crunch this through, I can get the same answers faster. And I'll show you how to do that when we do composition as well. This gives me 3, because this is 2 and 1, or 2 and minus. Oops. There's my eraser. Oops. That's fine. That's legitimately fine. Negative. So minus 1 gives me 3. Here I'll have f of 2 times, or f of 3 times g of 3, which is equal to minus, oops, 2 sets equals to minus 2. And the domain for all of these would be the same, right? Because it's just the intersection. So the domain of this, so F's domain is, let me just put in domain here. The domain here is, I have to be greater than or equal to minus 1. And the reason is that I need this to be positive, or be 0 or higher. And so I just solve, so x can be negative 1. This can be from minus infinity to 4 union 4 to infinity. Okay. Because I'm not allowed to use 4, because when I get 4 here, I have a 0 on the bottom. So that's the domain here. So the domain of both of these would be the intersection between these two. And so here I'd go from minus 1 to 4, and union 4 to infinity. And so this is the domain for this function. And this is the same here. This is the same. Okay, so That makes sense for the domains real quick. So those two are the same. Here, let's go ahead and crunch through this. So here, if I did this, x plus 1 over x minus 4, which I can simplify to x plus 1 times x minus 4. But notice here the domain here looks a lot better, right? But actually you have to put it in back here. So the domain technically is technically the same, because at no point can this equal 0. So it's technically the same, even though this, once you simplify it down, is not the same. It is. Don't worry too much about the domain on this one. It's just something it's good to know, but I won't test you on it currently. All right, so let's do compositions. This is where the bread and butter of this section is. Oh, I lied. We did the machine. I said we wouldn't see the machine ever again. I lied. We'll see it for one more second. So here, so f composed with g of x is equal to f of g of x. That's the way you say it. You actually read this. You actually read this from right to left instead of left to right. So you read it backwards. So just make sure you're being very careful. The reason why I want to show this is because here, if I have some machine, we'll show the machine function real quick. So here, if I have the machines, if I plug in x, it's going to go through g first, right? It's going to go through g first. It's going to produce me a g of x. And that's going to go through f, which is going to produce me an f of g of x. This will make a lot more sense when we crunch through it. Or here, if I start with an x, I'm going to hit it with g first, and it's going to become g of x, and then I'm going to take g of x, hit it with f, and that's going to move to f of g of x. All right, so let's do that with this right here. It's actually easier seen by example. All right, so this right here. So we have f composed of g of x, and so I almost always write it this way so I don't mess things up. So f g of x, what is g of x? Well, g of x is right here. So I'll have f of x squared plus 3. And then I'm going to plug this everywhere and I see an x. And so I'll have square root of x squared plus 3. And that's how you compose that function. Here, let's do g of f of x. And so this would be g of, so g composed of the function of x. And so this is the other way. So g, well, f is the square root of x. And so when I plug that in, I'll get, so everywhere I see x here, I'm going to plug in square root of x. And so I get square root x squared plus 3. That simplifies just to be x plus 3. Okay, so this one simplifies down to something a little bit nicer. You can compose functions with themselves. So let's do that. So here we'll have g of x. And so g of x, of course, is x squared plus 3. Then I can put that in. So everywhere I see an x, I'm going to plug that in. So I'll have x squared plus 3 squared plus 3, which is equal to, let's go ahead and FOIL that, x to the 4th plus 6x squared plus 9 plus 3. So that gives me x to the 4th plus 6x squared plus 12. So, and here I just FOILed it. So x squared times x squared is x to the 4th. X squared times 3 would give me 3x. There'll be 2 of them, so 2. So 6x squared, and then 3 times 3 would give me 9. Just in case where you put that one. And we can also do the same for the f of x is equal to, oops, I'm gonna skip too far for it. F of square root of x. So square root. So I'll have the square root of the square root of x, which is the same thing as saying x to the 4th. If you remember your power rules. All right. So let's do this last page real quick. And then we'll call it a day. Any questions? You guys done composition before? Yes, no? Yeah, okay, so most of you do, so I feel kind of bad because I want to rush through this so we get out on time, but if y'all have done it before, let me just crunch through this part real quick. So this is triple, and then I'll explain the word problem. The word problem is probably the most useful thing we do, even though it's the most awful thing we do. So here, if I have f of x is 1 over x, this is this, this is this. So here, if I'm going to compose it, if we're doing a large composition, we just do it one step at a time. Is that one and that one. So here, h of x, so the first thing I'm going to do is the f of g of h of x, which is x plus 3. I'm going to plug that into g. So here I'll get f of x plus 3 squared minus 2. That simplifies to f of x squared plus 6x plus 9 minus 2, so it'll be 7. And I plug that all into here, so I'll get equals 1 over x squared plus 6x plus 7. All right, so one of the things we can do is if, so we can always get to this point, but if we are just plugging in a number, just go ahead and plug in the values and calculate directly. And let me explain what I mean by that. Here, h of g of f of a half will give us 2. So here, 2. And then g of 2 gives us 2 squared minus 2 will give us 2. So then I'll have h of 2, because remember f of a half evaluates to 2, so I can just plug that into there. G of 2 evaluates to 2, so I plug that in there. And then h of 2 is equal to 5, and then we're done. Okay. My math teacher used to scream at us, the second function does go into the first function. X values reduce, so that's how I remember it. Well, you know, good old screaming, that always works, right? That was the old, this is a very old saying, which they never say anymore. Spare the rod, spoil the child. Well, it's because we don't believe in corporal punishment anymore for good reason, but I won't get into it. Be nice, treat everyone as a human, especially nowadays with everything going on. So, all right, so let's do this. So why do we care about composition function? What does that have to do with the price of tea in China? And so why does it matter to us? And so the reason we want to do this is so we can solve problems that are more complex in a simpler way. And so let's do this. So the ship travels at 15 miles per hour parallel to a shoreline, and the ship is 4 miles from the shore, and it passes a lighthouse at 2 p.m. Draw a picture that represents the distance of the lighthouse and the distance of the ship at any time it passes 2 p.m. Express the light is basically expressed as 2 functions. So let me just draw a picture real quick. Yep. So it's just, oops, hold on. So here we have a shoreline. We're gonna have a boat. There's a little boat. So we're traveling parallel to the shoreline. We're gonna have a lighthouse right here. Just gonna draw a lighthouse. I'm not gonna win marks on my art today. And so we know what this is. This is 4 miles, right? Because it's 4 miles from the shore. And then this is where the ship's at 2 p.m. And we know the ship's traveling this way at 15 miles per hour. Miles per hour. And I want to know what this distance is. This distance, we're going to call this S, and we're going to call this distance D. Okay. So we want to know what S is at any point past 2 p.m. So we're just going to say T equals 0 is 2 p.m. So that's just something to declare. When time is 0 is 2 p.m. and we're going to measure time in hours. Why? Because that's what we have here. So this distance D, for any given time is how much have I traveled down this part, is going to equal 15 times T, right? Because that's how many hours I've traveled past 2 p.m. is how far my little boat's gone, right? My little boat's gone that far. And given S, and if I want to know what S is, given D, well, what is that? Well, it's just a Pythagorean theorem. Here I have, this is a right triangle, right? Because it's traveling parallel. So this is a right triangle, so it'd be 4 squared plus D squared, right? And so that's what this distance, the square root of that. And so here, I know what this is, and then I can just compose the functions. I can just compose S of D of T, which gives us the square root of 14 squared plus 15T squared. And there we have our formula. So this gives us the formula, which allows us to say at any point, any time past 2 p.m., I can tell exactly my distance from the lighthouse. And how did I do that? I split it into smaller stuff. I could say, if I knew, can I tell what this distance is? Yeah, here's a function for this. And if I knew what this distance is, could I tell what this distance is? Yeah, here's a function for that. And then I just put the two together. So that's the point of composition of the function. The reason we teach it to you is so you can use it to simplify problems and then puts the parts together. So that's the reason we teach it to you. I don't know if it's really well explained when we do it. When we first teach you, it's like, oh, it's just fun, have fun. No, there's a reason for it. It helps you to solve really complicated things by breaking it down into its constituent parts. It's kind of like when you program, you break down your big program into its constituent parts, and you call functions. So, all right, guys, any dire questions from any of this?